Okay, hello everyone. We'll get started today. Today we'll be talking about authentication. We have two guest lectures, Isaac and Kate. I'll introduce them a little bit later. But before that, we have a couple of announcements. So let's get through that first. Okay, so PA6 for deployment is due this Wednesday at 11:59. That's technically your last assignment for the semester. And then after that, you have like your final project slash exam slash thing, which is like the hack challenge, which is the like a 2 week long hackathon that you get to pair with students from all the other courses, for example, like the front end courses, as well as the front end design course to build your own app. So just to talk a little bit more about the hack challenge, it's going to be 2 weeks long and it starts middle of next week. It's required because it serves as your final exam project. So for this class in particular, the hack challenge counts for 30% of your grade. You get to collaborate with people from the other courses, and it's pretty beneficial for you because you get to add another project to your resume. You can win real awards and prizes. So for example, there's categories like best UI, most creative, best backend, and you'll win something cool. Like for example, in the past, people have won like plushies and things like that, and like speakers, for example. So the kickoff is next Tuesday, 4/25, location TBD. And so we'll definitely make an announcement for more of the details on that in this week so that you can, plan accordingly and show up to kickoff. And then after kickoff, just like for a brief kind of roadmap of what it's going to look like, you'll then have like a team matching form where you can, if you have like friends in the other courses, you can prefer them to be on your team to work together, or be like matched with like random people as well, which I'm sure are very nice and you guys will get along. And then you'll also be able to prefer like prep a backend mentor. So one of the people on the core staff will kind of guide you along development of your backend, and it's kind of like your point of contact to reach out to should you have any questions along the way. And you can feel free to contact us if you have any questions. But yeah, be on the lookout for like an ed announcement or something with more details to come. You have any questions on the hack challenge? Okay. If not, the next thing I just want to quickly talk about is just resubmitting assignments. So we sent out an email like last week, as well as like before spring break, if you're potentially sort of like on the border or maybe in like the failing range of the course. Just a quick note, remember you need to have a 70% to pass this course with an S as opposed to a U. And now since the drop deadline has passed, we want to work with everybody who's still like remaining in the course. If you're definitely still interested in like remedying your grade and kind of bring it up to good status, if you feel that you haven't been, earning as high as you want on the assignments, or you haven't been as on top of like turning in your assignments. So there's a new like assignment opened on CMS for resubmitting your assignment. You can resubmit up to 3 assignments for a higher grade. That might change. I might have to do some recalculating on that, but yeah, necessarily you can like resubmit some assignments up to a higher grade. If we saw that you demonstrated effort on your first submission, such that like you actually like try and you earn some kind of credit on it, you can resubmit for up to a 7. Otherwise, you can submit for up to 6 points if you didn't turn in the assignment at all. And we'll make all of these assignments due by next Friday. So like the coming Friday after this week at 4/28. So that's around like when your hack challenge sort of like midpoint submission should be due. So beyond that point, you should really only focus development on your hack challenge app and not on these assignments anymore, which is why you'll have this week and like the majority of next week to work on any resubmissions of assignments if you need it. And details of this will again be made in an ed announcement. So make sure to keep a lookout for that. Any questions? Cool. So yeah, just to note that like essentially it shouldn't be sort of like too much of like a hurdle to kind of get these in and get like a satisfactory grade for the class. The hack challenge is again a good portion of your grade as well. So as long as you do well in that and you show kind of demonstrated effort throughout these assignments, if you want to like resubmit any at all, and also make sure to, if you fill out like the weekly feedback form, you can earn some credit there too. So it should put everybody in sort of like a good range to pass the class. Okay, there are no further questions. We'll introduce our guest lecturers for today, Kate and Isaac, if you guys want to come up and introduce yourselves to the class. Oh.
Hi everyone. Can anyone hear me? Okay, cool. I'm Kate. I'm currently a junior studying CS. I took this course fall of 2020, so my freshman fall, and then I taught the course last spring. So yeah.
I'm Isaac. Oh, I'm Isaac. I'm a freshman studying CS, and I took this course last semester. Mhm.
So yeah, we'll just get started with lecture today. So before we dive into the concept of authentication, we're gonna just quickly review what we've covered in this course so far. So we talked about the client-server model in week 1 and how you send data through the client to the server and you get some form of data back, and that's how your app sort of communicates and displays whatever is happening on the front end. And so these requests can contain a URL, a method, a body, and query parameters to pass in data and hit whatever endpoint and do whatever function you need to do. And then the responses you get back contain a body and a status code indicating whether or not you get a success or a failure response. And so many of the apps we've been building so far have been very basic. So for example, the Venmo we've been building, you can send and receive data, but you can't really have a user because you don't really have a password that's not very secure. And you can't really have like custom settings like friends and stuff. And we want to be able to incorporate users and different settings, content, social features, and the apps we build. And we also want permissions for resource access and manipulation. So for example, in Venmo, you want to only access your own money. And also in CMS, like teachers have different permissions for courses than students. So we need a way to identify users when making requests. And so how do we sort of verify who is sending these requests? Does anyone sort of have an idea of how we can verify who is sending requests to the server? No worries if not. So we want to like sort of basically send some form of user identification from the client to the server. And so ideally we'll have like some user body where some form of like data in the user for the user, like in the request body. And so something like this, like saying that the user is Rahi, but you can't really do that because the only way of sort of like identifying is through your user ID, but that's not always very secure because anyone can sort of know the ID. And so the way to really verify who is sending a request is through authentication, which
Okay.
Isaac is going to
Now
talk
I'm going to be
about.
talking a little about authentication. So first, as an overview, the gist of authentication is when you're including additional information in a request for the user identity. Like Kate said, this could be a password. We're going to talk about different ways you can verify a user. But obviously, as I'm sure all of you know, this is very important. Basically, every website you use, every app you use on a day-to-day basis requires authentication. And it's even more important for sensitive information like bank accounts, stuff like that. Once we pass in some sort of authentication to the backend, then we can validate the server request. That's what you guys are going to be learning how to do, how to validate that the password or whatever we're sending in to authenticate is actually the user's, and the user is who the user claims to be. And then after we're able to do that, then you'll know how to create specific permissions based off of user identity. And later in the demo, Joyce and Mateo are going to teach you how to create protected endpoints, which are basically endpoints that you can only use if you have the correct authentication. So how do we actually create this in the first place? Well, whenever you make an account, you need registration. And then after you register, you're going to log in. So as I'm sure all of you know, when you create or you go to some sort of website, they're going to ask you a lot of times for an email and a password. You put in this email and a password, and then we send it to the database where it's encrypted and stored. After you send this information into the database, you can store it. And then now, once we have the information in the database and you go to log in, you put in the same username, you put in the same password, and we can check to see in the backend if that username and password combo already exists. And if that combo exists, then we know that the user is valid. We know that the user is who they claim to be. And then this way we can allow them to access the request, access the routes that they want to access. Does anyone have any questions at this point? Cool. Before we talk more about authentication, the specifics of how we're going to do it, we need to talk a little about HTTP request headers. So far in this class, does anyone know basically how we've been sending information in requests. For example, in Postman, how are we sending information? How are we doing this? Yeah, exactly. So we're doing this in the body, right? Is there any other, maybe one other way we've been doing it? Think about when you make a request or when you're coding it on the back end, you have the body, right? What other place do you get information from? Yeah. Yeah, exactly. In the URL, maybe you want to include the user ID, maybe you want to include the task ID like you did in some of the demos. And these are all ways in which we can pass information into the backend. The HTTP request header is simply just another way we can do this. And the difference between this and the body and maybe the URL is that the request header contains metadata about a request. It's telling you about the request itself. For example, it can tell you about the content type. Maybe you're making a request uploading an image. Maybe you're making a request uploading a video. Maybe you're just uploading text. If we pass this information into the backend, maybe it makes their life a lot easier when they're processing these requests. You can also pass in cookies. I'm sure all of you, when you use websites, you see notifications or the site asking you whether or not you want to accept cookies and whether or not you want them to store your data. This is just another way for the backend to have short-term data and for you to pass in information beyond just the body and the URL. And thirdly, maybe we want to talk about the user agent. For example, I use Windows, Joyce, Kate, they use Mac. So our experience might be very different. In addition, if we use different browsers, for example, if a website works differently on Chrome or Bing or anything like that, you're going to want to know that information, which is why we might want to pass that in as well. But none of that is really important for today. Today, we're going to be specifically talking about authorization, and this is how we're going to pass our credentials in. And we'll talk a little bit more about this later. So here you can see an example of an HTTP request header. Don't worry, you don't actually have to code all of this, and I know it's really small. Postman actually makes it really easy for you to pass in authorization tokens, which we'll be talking about more later. But this is just an example of what a request header might look like. Does anyone have any questions before we move on? Okay, cool. So today we're going to be talking about 3 types of authentication. First HTTP basic, then HTTP session, and finally HTTP token. I'll turn it over to Kate now to talk about HTTP basic.
Yeah, so each of these authentication schemes sort of implement a sort of different types of authentication, and you'll be able to like identify it through your request header, which you'll see I think also in the slides and later in demo. But first we'll talk about HTTP basic. So how HTTP basic works is whenever you're like registering or logging in as a user, the front end sort of takes the username and password that you input and encodes it. And so encoding is basically just like taking a string and then adding a bunch of different like complicated, complex things. So it's more secure. And then you cache the encoded credentials on the front end, and caching is basically just like storing it short term on the front end side. And then you send these encoded credentials with every request to the server. And then the server then validates the encoded credentials to make sure you are who you are and sends the data back if it's a success. And so basically this is an example of how HTTP basic works. So this is like your request header, and then so you'll have like the authorization key, and then your values sort of like it starts with basic, which is like the type of scheme you're using, and then like the encoding of the username and password. And base64 is just like one of the many types of encryptions that you can use to take like a string and pass it into like a more complicated version, so it's like more secure. And so you take this like encoding, and basically the backend decodes it. Oh, Britt will tell you how to do it here, but basically your client registers the user, and then your server creates a new user and then returns a response, and then that new user is sent back to the client. And then so now you have like this new user, and then with the new user you have the username and password, and then you store that username and password encoded in the front end. And then whenever you make a request to the server, so let's say like you're trying to send money on Venmo, you'll send those like encoded credentials in the query header that you just saw, and then the server takes it and then decodes it, validates the password from the decoded values, and then if it's a success, then it'll return like a success response. Otherwise, it'll return a failure if it doesn't match. And so that's sort of how HTTP basic works. Does anyone have any questions about that? I feel like I went over that kind of quickly. Okay, cool. So HTTP basic has several benefits. So first of all, it's very simple. Because you're just like encoding it on the front end, it's very accessible, and like any front end client can sort of encode it, store it, and then send it to the back end. And so because of this, any client can use it, and you don't have to rely on a specific type of front end to like do anything. And then there are several drawbacks to this, because like whenever you're sending encoded credentials to the backend, your username and password are basically being sent in every single request. So anyone can take this query header and like decode it themselves and get your username and password. So it's basically exposed every time you make a request. And so the security of your requests are really dependent on the HTTPS, because if someone like sort of intercepts it and decodes it, then you're basically exposed. And so that's not always very good. And also, because your username and password pair are cached on the front end, whenever you like close your application or browser, that cache is sort of like destroyed, and then you'll have to like sort of like reauthorize yourself, which may be very inconvenient. But that's basically HTTP basic. If anyone has any questions, now is like a good time to ask. Okay, cool. So I think next we'll be going into HTTP
Next, we'll be
session.
talking about HTTP session, and we'll be talking about how this form of authentication kind of solves the drawbacks of HTTP basic. So when you're creating the user, a lot of it's the same as HTTP basic. You're sending the username and the password to the server, and the server is going to store your password encrypted. It's going to store the information, the other information you passed in with the body. However, the difference is with a session, or when you use session authentication, the server doesn't return the user back or just the user back. Instead, it also generates a session and generates a cookie associated with that session. And this way, it returns the cookie back to the user when you create the user. And now every time you want to access an authorized route, or a route where you need authorization, you can just send the cookie in. And then this way, the server can check whether or not that cookie is valid, whether or not that session is valid, and then give you permission to access those routes. Does anyone have any sort of idea why we might want to send in a cookie instead of just the username and the password? Kate talked about it a little in the previous slides and some of the drawbacks of HTTP basic. No. Shingo?
If anyone intercepts your network request and send in your username and password of your request, they can get your username and password and really insecure. But the cookie is much more complex to kind of break down, and hence would be more secure to send in the time.
Exactly. And I'll also talk about this a little later, but the fact that we have sessions now instead of just returning the username and password means that we can consistently recycle the sessions and consistently update the cookies to make our authentication more secure. Here's just an example of what a cookie might look like. It just has all sorts of information at the bottom. I know you can't see it, but it contains a little bit of information about the session. And this is how you're going to be validating it. So you're going to be sending this in instead of the username and the password. And here it's just highlighting where the session information is, but that's not super important right now. So when you register, you're going to register like normal, and then you're going to create the user. You're going to create the new session. And after you create that new session, you're going to create a cookie, and then you're going to return that cookie. This is just like any other request you might make on the backend, right? You send a request in with Postman, and in the response of the request, in the body of the response, you're going to have the information. And then now you can store the information on the front end. And every time you want to make a request, you send in the cookie. And then what's going to happen is on the back end, you're going to parse the cookie to get the session, information about the session. You're going to validate the session to make sure that the user is authorized, and then you can return your response. So this is the basics. So far, does anyone have any questions? Yeah.
Is there any way for people to like accept?
Mhm.
Like, I know the previous way,
Mhm.
it was that it was like exposing people out.
Mhm.
So the key is that the cookies.
Yeah, so you can still intercept the cookie, but we're going to talk about this actually probably the next slide about how it's actually still more secure than passing the username and the password. So just hang on tight for 1 sec. But you're absolutely right. Any other questions? Okay, cool. So when you create the session, right, you might want to create it with a time limit, say 24 hours, 1 week, maybe even longer. But eventually that session is going to expire, right? And once that session expires, the cookie that you created with that session is no longer going to be validated, right? Because your session has expired. And this goes back to your question about why the cookie is more secure. Because if this session is expiring, let's say every 24 hours, and I intercept a cookie, I'll only be able to use that to access your information for 24 hours. This also means that, let's say you logged on to some sort of device, you logged on to some sort of client, and for some reason you stopped using that device, right? Or if you take that device and you gave it to someone else, right? Maybe you sold it to someone else, maybe you need it repaired, and then they were still able to access your information because your session hadn't expired. Obviously, that would also be bad, right? So these are a couple of the reasons why we want to motivate having these sessions expiring. But one problem is when the session expires, yeah, no other people can no longer use the cookie, but the cookie I stored on my front end as well, I stored in my client, is also not going to work. So what we need to do is we need to return the response. Obviously, if the cookie isn't validated anymore, we're going to return a failure response. And at this point, what we had to do is we had to log in again. And like we did when we created the user, we stored the password in the backend. We stored the encrypted password in the backend. So we can revalidate that, make sure it's the correct information. And then we can create a new session. We can return a new cookie, and then we'll be able to access the routes and the data we want again. Does this make sense to everyone? Okay, cool. And this is just basically the stuff I already said. And now let's talk about some of the benefits. I've already been over this a little bit, but now instead of sending in the username and the password in every request, we're only exposing the cookie. And second of all, we can tune the expiration time between user convenience and safety. So for example, if I had a very sensitive app like Venmo where information is very important, you don't want people stealing your money, you might want to set a shorter time for the expiration of the session token. However, if you have some sort of app, like the app I'm working on for app dev volume, where what you do is you read student publications, it's not that much bigger of a deal if someone else is just reading articles using your account, because why would they want to do that in the first place? And it's not going to do any harm to you. So maybe you can set a longer time for the session token to expire. And this way, it's more convenient for the user because you don't have to log in as much. Obviously, there's still going to be some drawbacks. So the first thing is you have to save the session data in the memory. Otherwise, you wouldn't be able to validate whether or not the session is correct, right? You wouldn't be able to use the cookie to see if the session was valid. And that takes up a lot of storage. And the second thing is, if your cookies are ever deleted from your browser, then you have to log in again, which is going to be inconvenient. So now Kate's going to talk about the third and final authentication scheme with tokens.
Yeah, so tokens is the last one. And I guess just to like build off Isaac's point about why sessions and tokens are more secure than HTTP basic. I think like even if your token or session cookie gets like intercepted, like it's still more secure than HTTP basic, because HTTP basic, your like username and password are directly exposed to the like whoever's intercepting it. But even if you intercept a cookie, like your username and password will never be, or it won't be exposed like it will be in basic. So it's still like more secure than basic. But yeah. So now talking about token, how token works is we still send the username and password to the server whenever we're creating a new user or logging in. And then the server then validates the credentials and then generates and returns a unique access token. So this access token is different than a session because this access token is usually just like a string. And so it's a lot like less storage And this unique access token is then cached on the front end, and the client then sends this access token on every single request to identify the validated user. So it's a lot more like efficient because it's a lot like less storage because it's just a string. And this is sort of an example of the request header with HTTP token. So like before, we have the authorization, but the value of time is bearer. And bearer is just sort of like indicating it's a bearer token. You can have different types of like token authentication, but I think in this course, we'll probably be doing bearer tokens. And I think in demo, we're also implementing HTTP token. And so you have bearer, which indicates that this is a like token, and then you can have the access token after it. And then we take this access token and then validate the credentials of the user. And so here's an example of like users and tokens. So here you can see like this token matches ID 10 on the tokens table. And then so basically when we send this request, we see that this token matches some user ID, and then we can associate whatever this request is to user ID 20. And so this is sort of how the tokens work on the backend side. So we'll have a separate table for the users and tokens. And the reason we don't want to store the tokens with the users is because sometimes users can have multiple tokens. So for example, if you're using like CMS on your like iPad or your like iPad and your MacBook, you'll have different tokens for both of those like devices. So each user can basically have multiple tokens. So it's not like a one-to-one relationship. So that's why we want to have like multiple tokens. And then like a different table for that. And so yeah, basically you want like your users and you want to associate each token with some user. And so tokens sort of act like sessions and have an expiration time. So access tokens will expire after a period of time. And so if you accidentally expose your access token, it doesn't have like a super lasting effect. And so users can also request a new access token after existing ones expire. And we also have something called a refresh token. And this is sort of like a one-time use to replace the previous access token. So you'll see in a second like how you would use this refresh token. But basically, this is like how the token database schema is created. So each token has like a unique ID, just like any other table. And each token is associated with each user. So like when you pass in the token, you know like which user to sort of like which one it corresponds with. And then you have an access token, which is cached in the front end and used to send in any request. And you have an expiration date for that token. And then you have the refresh token, which you'll use to like refresh the access token. And once it's used, it'll expire. And so here's like an example of registration. So like when you're creating user from the client to the server, just like any other authentication scheme, you'll create a new user. But instead of creating like a new cookie or instead of creating a new cookie, you'll create new tokens. And so remember, that's just the access token and the refresh token. And then those tokens are then returned to the front end, and the front end stores that locally. And so then we have the access token. And so whenever we want to make a like secret request, we send the access token to the server. The server then validates the token. And then because we associate each token with a user, we can see like which user it's is associated with, execute the operation, and then return the response. And so if that token is expired or not right, then we can send a failure response back. And let's say like your token expired, that's when your refresh token comes into use. And so you take that refresh token and then you send it back to your server, and then we validate that the refresh token is correct. And then we create a new access token, a new refresh token, and the same thing happens again where you store it on the front end, and then we send that access token back and forth. And if something happens to it, we send the refresh token. And yeah, does that kind of make sense how like the tokens work? Okay, cool. So there's several benefits to tokens. So one of them is that the user credentials are sent a lot less frequently. And so like this is a lot better than HTTP basic because we're not sending the username and password like through every request. Also in cookies, because we don't have that refresh token, you have to like send your username and password again whenever your cookie sort of expires. But here, because we have that refresh token, we don't need to do that as often. And also we have the same expiration date accessibility where you can like tune it for user convenience and security. And it's also more scalable because you're storing a lot less information. You're just storing your access token and your refresh token, and those are just two streams. And so yeah, that's the final authentication scheme, and I think that's the one we're implementing in demo today. But yeah, I think now it's time for demo.
All right, so I just started up the app.py, what it would look like finalized. I'm going to run this request with an email and a password. And then if you see down here, we have a session token, a session expiration, as well as an update token. And then front end can then use these two to continuously get requests authenticating each user. The idea of using the session token is there's many benefits, and we'll get into those as I go through some of the code. Okay, so first I'll close out the finished version. We'll go to the starter code, and I'm going to quickly run through all the files so that we can see what we're working with here. Okay, so previously we've used just app.py and db.py, and these are going to work the same way they did before. But additionally, we're going to use this users DAO. And so the users DAO is for sending data. And so it stands for like data something organization, data access object file. And this has its own methods. If you look here, the first three are going to be those helper methods. So get user by an email, get user by a session token, or get user by an update token. And then we're going to write a few more methods down here. One is going to be verify credentials. And so this is given a user's email and password, verify that those credentials are correct, like for a certain user. We're also going to have creating a user. So that's given an email and password, create that user with that email and password. And then lastly, renew a session. And what this is going to do is given an update token, you're going to give back a refreshed access token as well as a new update token. App.py. First thing we're going to want to add to app.py is we want to import our new file. So it's going to be users DAO. And if you see, we have our initial success response, failure response, helper functions. We have a function that's called extract token. And if you remember, this is going to get that authorization header and then just take out that bearer part. So you get the actual token from it. We have our base endpoint, just hello world as an example. We have register an account. So this is when you have a new user and you want to register for the first time, as well as logging in. So this is for an existing user. If you have the username and password or the email and password, you can log into a user. And then we have update session. Update session is to update that user session given those tokens that we have. Then we have secret message. And so this is for verifying a session token and returning a secret message. We'll go more into this on the lecture on Wednesday or on the demo on Wednesday. Lastly, logging out for a user. We're going to go into db.py to explain this real quick. If you see, we have this class user. And so we have our table name as well as an ID. This is that primary key. Then we have some user information. In this case, it's going to be email and password digest. So what happens is we don't actually want to store a password in our database. If someone gets access to our database, we don't want to leak all of our users' passwords. So instead, we're going to like encrypt this and store an encrypted version on our backend. And so that goes into another reason why we don't want to be sending email and password as a request every time, because encrypting a password from a user is hard because users' passwords are very guessable and they're very short. So it has to go through a lot of encryption and it takes up a lot of computing power. Whereas just making an access token, because it's just a random list of like letters and numbers, it's much easier to come up with one that's random that no one can really guess. And it's much quicker to do that. Additionally, we're going to be storing the session token, the session expiration, and the update token. And we went over all of that. These are going to be the session token and update token are going to be strings. And then the session expiration is something that's called a date time object, which we'll get into later. We have an initialize function. So this is when you first create a user. When you first create that user, you only have their email and their password. And so you're going to set that password digest by using this bcrypt.hashPassword function. And then you're also going to want to renew that session, which is going to set that session token, session expiration, and update token. And then here are some more helper functions. So you have this URL safe base 64. So this is for creating that session and update token, and it just creates like a random like hashed token. And so this is a really quick function compared to like encrypting a user's password. Then we have the renew token or renew session, sorry. So this renews the session, but it doesn't only renew the session if the session token has been passed in. It can also renew it when we first create a user. So if you saw before, we'd call that function right here. And so this will set that session token, session expiration, and update token. So if you see, we're setting the tokens using this like random base 64 generator. And then for the session expiration, we're going to set the expiration to datetime.datetime.now, which gets us our current time using this datetime module. And then plus datetime.time delta with days equal to 1. So it'll give us the whatever time it is 1 day in the future and set that to be the session expiration. Next, we have verify password. And so this uses the check password function. Next, we have verify session token as well as verify update token. And if you see, these two methods are much quicker than to be checking this encrypted password against the initial password against this encrypted password that we're storing. So this is why we want to use these session tokens. So with